Hello guys, and welcome to this presentation on P2.2, which is Newton's laws. So, forces and interactions. Pairs of forces occur when objects interact with each other in contact or non-contact, and each force acts on a different object. Each force is of the same magnitude and it's the same type of force. So if one's friction, the other is also friction. And the forces act in opposite directions. That's Newton's third law. For every action, there is an equal and opposite reaction. Probably his most famous law. And that's basically what it means. So there are two types of forces, non-contact and contact. Non-contact, gravity, magnetism, electrostatics. And then contact, there's a few more. So friction, drag, which is more commonly known as water or air resistance. Normal contact force, upthrust, and tension. So free body diagrams are diagrams which you can draw to show forces acting on an object. So the picture shows you how to draw it. You have to identify all of the pairs of forces which include the object, and then you isolate the forces that are acting upon the object that you want to draw the free body diagram about. So then to calculate resultant force, you just you must know which direction is positive. So for example in C, let's say the up arrow was 5, the down arrow would be -5. So then you add them together and it would result in 0, which would mean that there is no no resultant force acting on the book. And to work out forces at angles, you use Pythagoras as shown in the diagram in the bottom right hand corner. So Newton's first law says that an object will stay at rest or move with uniform velocity unless a force acts upon it, which means that if the resultant force is 0, then speed and direction, in other words velocity, of an object does not change. However, it does not mean the object is stationary, for if it's already moving, it will continue moving. And when the resultant force is 0, it means the object is in equilibrium. So Newton's second law says that when the resultant force is not 0, the object can change speed and or direction, and therefore the object will accelerate. And then his famous formula, which is force is mass times acceleration, or more commonly known as F equals ma. So, for example, when you're falling, you start accelerating because the resultant force is negative, so downwards, as the Earth has a greater force on you in gravity than the air resistance. But eventually, the air resistance equals the gravity's force, so you don't accelerate anymore, and that's called terminal velocity. So the forces are cancelling each other out, so you just continue falling at constant velocity. And then if you deploy a parachute, the air has a greater force on you, which means you decelerate until you reach a lower terminal velocity where the forces are equal. So forces at an angle, let's say on a hill, it's quite a common one. You have to make sure that all the forces are 90 degrees to each other. So you can do this by using trigonometry. So in this diagram, you use cos to find out the length of A and find out the length of B. So if the weight, which is the downwards force, is 500 newtons, and the angle between A and the weight is 20, A equals 500 times cos 20, and that's just basic trigonometry, which is 470. And then B is 500 times cos 70, because that they make up 90. And then when you have all of the forces worked out, you can work out the resultant force. And then once you work out how much is upwards and how much is to the left or right, you can then use Pythagoras. You can use Pythagoras to work out the exact angle of that resultant force as well. So momentum is measured in kilograms meters per second. Bit of a mouthful. But that makes it easy to remember the formula because it's just mass times velocity. And the law of conservation of momentum states that the total momentum before must equal the total momentum afterwards, which means that, for example, if two cars hit, they'll both have quite a lot of momentum before. So they're going quite fast and they're quite heavy. And the total momentum afterwards of them like breaking apart will be the same as their momentum of collision. So obviously, if you're going faster, the collision is going to be worse. So, for example, this question here, you have a ball weighing 100 grams travelling at 10 meters per second. It hits another ball of the same weight and they stick together and both move forwards. What speed would they move forward at? So the initial momentum is just mass times velocity, which is 1,000. And here, because all of the masses are in grams, we don't have to convert it to kilograms because it will still give the same result. So then you have that 1,000 is the two balls put together, so 100 add 100 times the speed. So then if you rearrange it, it's 1,000 over 200 is equal to the speed. So therefore the speed of the balls after would be 5 meters per second. So work and power. Work is doing forces which then transfers energy between forces. So for example, when a car is driving along, it has kinetic energy, and then friction converts that energy into heat energy, which is transferred to the surroundings. So, or when you work to lift something, you're transferring energy to a gravitational store. Work done is force times distance, and work done is measured in joules, but it's also equal to 1 Newton meter, because a Newton meter is mass times acceleration times distance, since it is force times distance, and force is mass times acceleration. So therefore it's 1 kilogram times meter per second meter squared over second squared, which is equal to the equation for kinetic energy, which is measured in joules, which is half mass times velocity squared. And then power is the rate at which work is done. So therefore it's just work divided by time, like with anything, how you find out like the rate of something going on. And we use the time in seconds. And you usually see electrical appliances are measured in power, since that's a lot easier to measure. And that's it. Thanks for watching, guys. See you in the next one. Bye.